Hi Logic students, this is a video on something that is important for the whole of chapter 7. Certainly it is important for accomplishing the proofs and other transformations of symbolic formulae that are important for solving the exercises this week. It's something called quantificational equivalence, and on the face of it, the term is somewhat intimidating. It appears to be referring to a very complicated idea, but it's actually a fairly simple idea. And I try to capture it here in terms of the thought that when you phrase a statement by using the word all, you can actually always say the same thing by using the word some, and vice versa. So there's always a way to translate a statement that is phrased in terms of all into a statement that says some, and vice versa. Anything phrased in terms of some can be rephrased in terms of all. And this is accomplished by manipulating negations in a way that is actually simple and intuitive, and that we can just simply look at by considering some examples. So, for example, the statement, not everything is beautiful, if you think about it, is obviously equivalent to something is not beautiful. If not everything is beautiful, then something is not beautiful. So with our symbols, let's do not everything is beautiful first. So that will be, it's not the case that for all x, x is beautiful. Okay, this will be the symbolization for not everything is beautiful. And from a logical standpoint, in terms of the symbols, this is equivalent. Let's put the triple bar to say if and only if, so complete logical equivalence. It is equivalent to something is not beautiful. So not everything is beautiful is, it's not the case that for all x, bx. And this is equivalent to there is an x such that x is not beautiful. Something is not beautiful. Now, a simple way to think of these equivalences is in terms of, if you like, pushing a negation through a quantifier. So let me rewrite the first statement here. Imagine that you want to take this negation and push it through this quantifier to get it to the other side, to get it here. Okay? You can do it as long as when the negation goes through the quantifier, you change the quantifier from universal to existential. So maybe this is a simple way to think about these transformations. If I want to bring a negation in, I want to get rid of this negation at the beginning of the formula and push it through the quantifier and place it next to the b, then I can do it as long as I change the quantifier. So I'm going through here, so I'm putting the negation next to the b, and I change the universal quantifier to the existential quantifier. And I get my equivalence. And it works the other way around. If I want to take this negation and extract it and put it on the other side, I can do it as long as I change the quantifier to the universal one. So think in terms of pushing the negation through a quantifier. Every time you push a negation through a quantifier, you can move it to the other side, but you have to change the quantifier from existential to universal or from universal to existential. So not everything is beautiful is equivalent to something is not beautiful. That's one form of quantificational equivalence. Here's another example. If you want to say nothing is beautiful, that is equivalent to everything is not beautiful. So let's do it again. How do you symbolize nothing is beautiful? You'll use a negated existential quantifier. It's not the case that there is an X such that X is beautiful. Okay, so now do that little trick with pushing the negation through the quantifier. If you want to push it to the other side, you'll come up with the negation next to Bx, but the quantifier needs to be changed to universal. So for all x, not Bx. You see the equivalence? Nothing is beautiful. There's not an x such that Bx is equivalent to for all x, x is not B. For all x, it's not the case that for all x, it's not the case that x is beautiful. So nothing is beautiful is equivalent to everything is not beautiful. Okay, so this little trick with pushing the negations through quantifiers does help remember these things. What about situations where there's no negation in front of the quantifier at the beginning? Say that I want to say everything is beautiful. Well, that too can be translated in a way that is consistent with the principles that we were just talking about. Everything is beautiful. This would be the simplest form of quantified statement. So for all x, b of x. This statement is equivalent to there is nothing that is not beautiful. So it's not the case that there is an x such that x is not beautiful. Okay? Now, you may wonder, well, what happened to that idea of pushing the negations through the quantifier and moving them to the other side and flipping the quantifier and changing it from universal to existential? This situation doesn't seem to exemplify that pattern, but actually it does. Remember that any statement is equivalent to itself preceded by two negations, right? Think about it. If you say it's not the case that it's not raining, that's a different way to say it is raining. So any statement is always equivalent to itself preceded by not two times. So for all x, Bx is equivalent to it's not the case that it's not the case that for all x, Bx. But then you can do the trick by pushing this negation through this quantifier over here to this side, right? So you're going to leave this one in place. The second one you push through, so you'll change the quantifier to existential. That negation, the second one in the first formula, gets to the other side, and then you have Bx. So again, you end up with this formula. There's not an x such that x is not B. So you see that the trick of pushing the negation through a quantifier does work, even when initially it doesn't seem like there are negations in front of the formula. And finally, what happens when you have a simple existential statement, such as something is beautiful? Well, that can be rephrased as not everything is not beautiful. That's a different way to say something is beautiful. So something is beautiful, very simple symbolization. There is an x such that x is beautiful. This will be equivalent to it's not the case that for all x, x is not beautiful. And again, you can see that the trick with the negations and pushing them through does work because because there's an x such that b of x is equivalent to, it's not the case that there's an x such that x is b. So let's leave this one in place. This one we push through to put it on the other side. So we flip the quantifier. It becomes for all x. This negation gets to the other side. And then we have bx. Okay? So these are the quantificational equivalencies. And they work with the quantifier regardless of the formula that follows the quantifier, because sometimes you have simple things after a quantifier, such as in this case, just bx. Sometimes you have things that are a bit more complicated. So, for example, imagine that you had something more complex, something like, not super complex, but there is an x such that px and tx. Say that you want to say that some people are tall. So that's one way to do it. There's an x such that x is a person and x is tall. So by quantificational equivalence, this would translate to not all x are such that it's not the case that px and tx. Okay, you see that the same thing is happening here. The bx remains the same, and what you do is you transform there is an x into it's not the case that for all x not. So you take that this translates to this. But that can happen whether you have just bx after the quantifier or whether you have something longer like px and tx. So here, this is transformed, just like up there, into this. Okay, so keep in mind that you can always use this quantificational equivalence. It's very useful when it comes to proofs and other, like I said, transformations of formulae that you have to do. Thank you, and I'll see you in the next video.